Hello friends, welcome back to this online lecture series on earthquake resistant design of structures. In the previous lecture, we have started the discussion regarding one very important feature for the good performance of reinforced concrete buildings when subjected to lateral loads, and that is the ductility, right? So in the last class, we saw the definition of ductility, the significance of ductility, and at the same time we discussed the factors that affect the ductility, that is factors that increase the ductility and also the parameters that will result in the decrease in the ductility. So now the next phase is what we are starting in this lecture today, that is the application of ductility in the real life structures, and that can be achieved only by means of following the guidelines that are given by IS 13920, that is the Indian Standard Code, right? So we will understand some of the prerequisites that are mentioned in the Indian Standard Code for the application of the ductility in case of reinforced concrete buildings. So let us start today's session, where we'll be discussing first the application of ductility and the prerequisites that are there that are mentioned in IS 13920. So if I talk about the application, that in which type of structures or what type of structural systems can I apply the concept of ductility, then the guideline is clearly given by IS 13920, and these guidelines are mentioned over here as you can see in the slide. That is, the standard address is the lateral load. The standard address is the lateral load resisting structural system for RCC structures composed of the following types of system, where the first type of system is the RCC moment resisting frame system, that is, which is consisting of beams and columns only. Second type of system is the RC moment resisting frame systems along with the unreinforced masonry infill walls, where the infill walls will not be taking part in the lateral load distribution, they will be only acting as a partition wall. Then the third type of the system is RC moment resisting frames with structural walls, where you can say that the system is going to be a combination of columns and shear walls both, right? And lastly, the fourth system is only the RCC structural walls, where the entire system is composed of structural walls only, that is the shear walls. No columns are present in the system, only the shear walls are present, right? So these are the four basic types of structural systems where the application of IS 13920 and the concept of ductility can be applied. Then the other criteria is that all the structures, when we talk about the structures, then all the structures that are lying in seismic zone 3, 4 and 5, that is the higher seismic zones, in all these three zones, the application of 13920 is compulsory for all type of structure, whether it is a ground story structure or whether it is a high-rise building or a skyscraper. And lastly, if the construction is being done monolithically, then also the application of IS 13920 is made compulsory, right? So these are 6 different categories where the application of IS 13920 is going to be there in case of reinforced concrete structure. Now there are certain exceptions also. So we look at the exceptions also. So where this application or the concept of IS 13920 cannot be done. So the first case that it is mentioning is that the precast construction. That is, if the elements are prefabricated in some shop and then they are transported by means of some medium and then they are erected by means of crane at the side, then on these type of structures the application of ductility will not be there, right? Then the second is the pre-stressed concrete, where the pre-tension structure and the pre-tension concrete and the post-tension concrete are there, where some kind of stress application is done for the load transfer mechanism. Then also in that case, that type of structure or that type of structural system, the application of IS 13920, that is the concept of ductility, cannot be applied. And third is the flat slab system. But in case of flat slab system, there is one criteria, and that is if the flat slab system is not having appropriate or sufficient lateral load resisting system, then only the concept of ductility or the guidelines of IS 13920 cannot be followed, right? So I have shown the figures of all threes, where the first sketch is showing the figure of the flat slab system. Second is that for the second one is for the pre-stressed concrete, and third one is the precast construction, right? In all these three cases, one thing is very important, that is, if along with this type of construction, if the system or the lateral load resisting system is such that the ductile behavior cannot be achieved in the building, then these three exceptions are going to be there. If the system is detailed in such a way or the system is planned in such a way that the lateral behavior can be achieved in the form of ductility, then the application of this type of systems application can be possible in these three systems also, right? So this thing is a very important point to be kept in mind. There is not clear cut guideline that you cannot follow at all, but if the system is planned in such a way that the transfer of forces happens in such a manner that the ductile behavior is achieved, then it can be applied to these three type of systems also, right? Now we next come to the criteria of materials also. What we have seen earlier is the type of structural system where the application can be done. Second, the exceptions we have seen. Now we come to the criteria of material also. So when I'm talking about the materials, then basically the design and construction of buildings shall be following the guidelines of IS 456. The guidelines of IS 456 have to be overruled only in case when these clauses that are mentioned over here are going to be followed. That is, if the building is located in seismic zone 3, 4 and 5 and the height of the building is greater than 15 meters, then the guidelines of IS 456 has to be overlooked by the guidelines of IS 13920. Same time, the minimum grade of concrete has to be M20 for all types of buildings. But if the building is located in zone 3, 4 and 5 and if it is having a height more than 15 meters, then the minimum grade of concrete as per IS 13920 shall be M25. Now again, one thing important to note or understand over here is that depending upon the climatic conditions, the concrete grade can alter. That is, if I am having a very severe climatic conditions, then in that case the exposure condition that is mentioned in IS 456 will be the governing concrete case. That is, for example, if I am going to construct a building that is going to be located near the seashore, then it is going to be considered under severe exposure condition, and in that case M30 is going to be the minimum grade of concrete that I have to follow, right? So these are general guidelines that are given. However, in case of exposure conditions, the guidelines or the clauses that are mentioned in IS 456 shall be considered as governing, and they are to be followed as far as the concrete grade is concerned. Then the other criteria is regarding the selection of grade of reinforcing bars. That is, the minimum grade of reinforcing bars should be Fe 415. It can be Fe 500. It can be Fe 550 as well, right? But the minimum grade is Fe 415. And lastly, the ratio of ultimate strength to the actual 0.2 proof strength should be at least 1.15. So that can be also achieved, or that can be also cross-checked once the property of the material is available with us, right? So these are the guidelines, or these are the criteria for the selection of materials where the ductile detailing is likely to be followed. Next we come to the criteria for analysis, right? So in case of analysis and design, the task that is going to be, or the important aspect that we need to keep in mind, is regarding the modeling of the structure that we are going to do in the ETABS or the StatPro software. So sometimes this confusion is there, which are the structural elements or non-structural elements should I model and up to what extent. So regarding this also, IS 13920 is giving you a clear cut guideline that so if so and so is the case, then it has to be modeled, otherwise it is not to be modeled. For example, that it is mentioned that the lintel level beams that are we provide, that is known as the lintel beams, right? So in case the lintel beams are there, then lintel beams should not be integrated on site with the columns, and if they are integrated, then what is to be happen is that these beams are to be even modeled in the office also, in the model that you are going to prepare, right? Usually we consider the lintel beams as a non-structural element. So as a result of that, we do not model that particular thing in our ETABS model or the StatPro model. But sometimes if the height of the floor is more, and if we want to take the advantage and break the column height, then we may pass the lintel beam through and through around the periphery of the building. If such is the case, and if we want to take that advantage of breaking the height of the column, then in that case the lintel beam has to be modeled in StatPro or ETABS. And when you will model that particular thing, then it will become a part of the lateral load resisting system, and the lateral forces will also be transferred to that lateral beam, the lintel beam, and that particular beam also has to be designed according to that criteria as well, right? And second thing is the application on site. So application on site is such that if you are not modeling, then that particular lintel beam or the reinforcing bars of the lintel beam should not pass through the columns on site as well. They have to be stopped at the face of the column, right? Then and only then the whatever assumption or whatever the model that we are working or making in the office, that same thing will be applicable or same thing will be visible on site as well, right? And what is going to be the disadvantage, that if you are going to integrate these reinforcing bars of lintel beams in the or through the columns, then as a result of that the height of the column will reduce, and as a result of that the short column effect is likely to introduce. And that is why IS 13920 is telling that in the first instance or the regular instance, the lintel bar should not be taken through. Then the second case is that if the plinth beams are there, landing beams are there and the landing slabs are there, then these three elements should be integrated with the columns on site, and at the same time they should be even modeled in the office also. That is, when you are going to prepare your model, then the lintel beams, then the plinth beams, the landing beams and the staircase slabs also should also be modeled in the ETABS or StatPro, and sufficiently the behavior should be studied accordingly. Then the other thing is that the structure should have sufficient amount of continuous frames in both the directions to resist the forces, because earthquake is going to be acting in X direction also and Z direction also, right? So it is mentioning that sufficient amount of moment resisting frames should be available in both the directions, that is X direction also and Z direction also. Then irregularities such as plan irregularity and vertical irregularity should be avoided. That is, the setbacks in the plan and setbacks in the elevation should be avoided. And at the same time, the floating columns or the stubbed columns should also be avoided, because when you are going to introduce floating columns, then there will be sudden change in the stiffness, and the sudden change in the stiffness may result into stiffness irregularity, right? So as a result of that, floating columns should also be avoided. And if any of the irregularities cannot be avoided, then in that case IS 13920 is clearly suggesting that non-linear analysis of this particular type of building should be done in order to control the damage of life, damage of property and loss of life. Right. Next we come to the criteria for design. We have seen the criteria for material, we have seen the criteria for analysis. Now we have to consider the criteria for design also. So when you talk about the design criteria, then it is telling that the structural layout should be simple and regular in plan, regular in shape. That is, irregular shape should be avoided. Right? Regarding regular shapes and irregular shapes, vertical irregularity, horizontal irregularity, we have discussed in the initial lectures where we have seen that if the length of the plan is too much, then also it is going to generate a lot of seismic stress. If there is sudden change in the stiffness of the building, then also there is going to create a problem. And that is why it is saying that the shape should be simple and regular in nature, right? That is why the offset in the columns, that is floor to floor offset, should be minimum, beam to column offset should be minimum. And at the same time, if there is change in the stiffness, then change in the stiffness should also be gradual in nature. Then the other criteria we have seen in the last lecture, that is, the tension reinforcement should be minimum and the compression reinforcement should be maximum. Why? Because if the tension reinforcement is there, then brittle failure is likely to be promoted, and in case of compression, if the compression steel is more, then in that case the ductile failure is going to be promoted. So as a result of that, the tension reinforcement should be minimum or it should be within limit as compared to that of the compression steel ratio. Then the other aspect is the beams and the columns, right? The beams and the columns in the reinforced concrete frame should be behaving in such a manner that the inelasticity is limited to beams only and the columns should be remaining elastic in nature. Now how this particular thing can be achieved? Then this particular thing can be achieved by means of ensuring the moment carrying capacities of beams and column. That is, the sum of moment carrying capacities of the particular beam column joint. That is the for example, this is the beam column joint. Then the column that is above and the column that is below, the moment carrying capacity, that is the sum of moment carrying capacity of the column above and column below, should be such that it should be greater than the individual moment carrying capacities of the beam in both the directions. That is, the beams that are coming in this direction also and beams that are going in the other direction also, right? So if the moment carrying capacity of the columns is more, then as a result of that, the columns are going to be elastic in nature and the beams are going to be inelastic in nature. Then the shear reinforcement should be provided in an adequate manner, so that as a result of that, the shear failure in the beam can be avoided, because we have seen that shear failure is also one of the critical criteria. In order to ensure that the shear failure does not happen, IS 13920 is telling that the lateral reinforcement should be provided. Then the other design criteria that is to be kept in mind is that the laps and the anchorage splices should be properly bonded with the concrete, as a result of which the bonding failure can be avoided in the concrete, right? So for that also the different guidelines are given in IS 456. These guidelines have to be followed and the anchorage length and the bond length has to be checked. Last but not the least, three other criteria that are necessary for the design point of view. These criteria are that the stirrup should be provided in order to increase the shear resistance, such that the shear strength of the beam is going to be more as compared to that of the flexural strength. And when this particular thing will be happening, then as a result of that, the confining zone, that the concrete section will be confined properly, and when the confining will be done, then as a result of that, the reversal of stresses shall be controlled, and due to this, the failure in case of shear failure will be avoided, and as a result of that, the brittle failure of the structure can be avoided. Then reversal of stresses have to be purely accounted for. That is also we have discussed. And the last thing is that the beam column connection should be monolithic in nature. That is, they should be casted simultaneously at the same time on the side. Right. So that is all for the different criteria that are there for the material. Then we have seen the design criteria for the analysis, and lastly we have seen the criteria for the design. In the next lecture, we will be discussing regarding the criteria for introducing ductilities in beam in order to ensure that the behavior of the structure is good enough to resist the lateral forces. Stay tuned for the further lecture.